In this video, we are going to cover the concept of fractions. So let's get started. What is fraction? A fraction is simply any number written in the form of x over y, whereby y is not equal to 0. Anytime you have numbers written in the form of one number at the top, another number at the bottom, separated by a factor of division, whereby the number at the bottom is not equal to 0, then you are looking at fraction. Now, we have some examples of fractions which includes 1 over 2, 2 over 3, 5 over 11, 7 over 8, 9 over 12, etc. Now, one good thing about fraction is that it always has two numbers, the one at the top and the one at the bottom. And another important thing you need to know about fraction is that the one at the bottom must not be equal to 0. As a matter of fact, 1 over 0 is not a fraction. 2 over 0 is not a fraction. As far as the denominator, the number at the bottom, is not equal to 0, then you have a fraction. But once it's equal to 0, then what you are looking at is no longer a fraction. Now, how does a fraction, what are the constituents of a fraction? Like I said earlier on, a fraction is made up of two parts. The number at the top and the one at the bottom. The number at the top is called the numerator, while the number below is called the denominator. The number at the top is called the numerator, while the number bottom is called the denominator. So feel free to tell me what the numerator of this fraction is. 2 over 3. What is the denominator? What is the numerator? Of course, you got it. The numerator is 2. 2 is the numerator, while 3 is the denominator. Always remember that. In a given fraction, the number at the top is always called the numerator, while the one at the bottom is called the denominator. Now let's talk about the types of fractions. There are two basic types of fractions, which are proper fraction and improper fraction. Now, what is a proper fraction? A proper fraction is simply that fraction whose numerator is less than the denominator. As a matter of fact, it is a fraction that contains the denominator having a greater number than the numerator. Example of proper fraction is 1 over 2, 3 over 5, 7 over 11. As far as the numerator is less than the denominator, what you are looking at is a proper fraction. Now, what is an improper fraction? An improper fraction is simply the opposite of a proper fraction. It is a fraction in which the numerator is greater than the denominator. Examples of improper fractions are, we have 11 over 7, we have 12 over 3, we have 13 over 5, we have 19 over 2. As far as the numerator, the number at the top, is greater than the denominator, you have an improper fraction. Now, there is another important type of fraction which we call a mixed fraction. Now, what is a mixed fraction? A mixed fraction is simply that fraction that consists of a whole number and a proper fraction. Anytime you have a fraction in which contains a whole number attached to a fraction, we call it a mixed fraction. Examples of mixed fractions include 2 whole number 1 over 2, 3 whole number 3 over 5, 8 whole number 1 over 11. As far as a fraction is attached to a whole number, what you have there is called a mixed fraction. Now let's take a look at conversion of fractions from one form to another. Now the first one on the list is conversion of mixed fractions to improper fractions. How do we take care of this? How can we convert a mixed fraction to improper fraction? To do this, what we are required to do is follow a simple step, and that is what? Step 1, take the denominator and multiply the whole number. Step 2, add your answer to the numerator. Step 3, divide by the denominator. That's all. Now, if to convert a mixed fraction to improper fraction, what you do is simply take the denominator of the improper fraction, of the mixed fraction, and multiply it with the whole number. And then step 2 says add your answer to the numerator. And then step 3 says divide it by the then denominator. So let's take an example to understand what we're talking about here. So let's say we have 2 whole number 3 over 4. This is a mixed fraction. So let's convert this mixed fraction to an improper fraction. So to do this, let's go with the first step. Take the denominator and multiply the whole number. Notice that this fraction is made up of a whole number, this is the whole number, this is the denominator, and this is the numerator. So to take care of that, we take the denominator 4 and multiply the whole number. So what we have is 4 times 2, and that is what? 8. Then the second step says add your answer to the numerator. So we have 4 times 2, which is 8. 8 plus 3, and that is what? 13. 8 plus 3, sorry, is 11. And then the next step is to do what? We say that we should divide the answer by the denominator. So we divide 11 by what? Denominator, which is 4. And that is it. We have converted 2 whole number 3 over 4 into a mixed and improper fraction, which is 11 over 4. Notice that the reason why it is an improper fraction is because its numerator is greater than the denominator. So let's take another example. Convert 2 whole number 3 over 6 to an improper fraction. So to do this, what do we do? So let's quickly stick to the step. 6 times 2 is what? 12. 12 plus 3 is what? 15. And we divide by what? 6. And that is the answer. So you can play around with as many examples as possible regarding conversion of mixed fractions to improper fractions. So let's take the final example. What if we have 1 whole number 1 over 2? How do we take care of that? So to deal with this, we simply apply the rule. 2 times 1 is 2, plus 1 is what? 3. And that is what? 3 over what? 2. That is the answer. So that is it for conversion of mixed fractions to improper fractions. Now, how about the opposite, the reverse? How can we convert an improper fraction into a mixed fraction? To do this, let's say we have an improper fraction 3 over 2, and we have to convert it to a mixed fraction. To do this, we simply go ahead and divide it. Since we are sharing 3 oranges among 2 persons, what do? We simply note how many it is going to go them. Now, if I have 3 oranges and I want to share it to 3 persons, how will it go? We simply say this is the orange, 3 oranges, to be shared among two persons. So first of all, each person gets one orange. And how many oranges left? One. So what I'm going to do is what? I will write the one orange that each person got, and that is what? One whole number. Now the remainder is only one orange that is remaining. I will write it as 1 and then divide it by the denominator, which is 2. I have converted this from mixed fraction, from improper fraction to a mixed what? Fraction. And that is how you take care of that. So let's take another example. If I have 11 over 2, how do you convert this to a mixed fraction? So to take care of this, we simply do what? Share 11 stuff among what? Two guys. So to share among two guys, we have what? 11 oranges. So these are the two guys. So let's share 11 oranges among them. So we share 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice that how many does each person get? Each person gets 1, 2, 3, 4, 5. Each person gets 5 oranges, remainder what? 1. So we simply write it as what? 5 oranges, 5 whole number. Then the remainder is 1, so you write 1 out of what? 2. And that is how to convert an improper fraction into what? A mixed fraction. Now we are not going to perform any conversion on a proper fraction because as its name implies, this is the unique fraction, a unique way of representing a fraction. So it is normal to represent a fraction as a proper word fraction. We can only do something on improper fractions and mixed fractions as the case may be. Now let's take a look at some arithmetic operation with fraction. Arithmetic operation with what? Fractions. Now, fractions can be added, can be multiplied, can be divided, and can be what? Subtracted as the case may be. But before you start adding or start subtracting or multiplying or dividing fractions, there are a few things you need to understand. And what are those things? You need to understand the concept of LCM. LCM is an acronym which stands for lowest common multiples. Now, what does that mean? LCM is of a number is simply the lowest numbers which can be multiplied together to form that particular word number. So let's say I ask you to find what. Let's say you are asked to find the LCM of 12. What is the LCM of 12? LCM of 12 simply means what small numbers can I multiply together to have 12. So to find these small numbers, we can do that by simply division or by inspection. So let's quickly do that with a division. So to find numbers that small numbers that can when multiplied together to have 12, we simply ask ourselves, what number can we use to divide? What number can divide 12 without a remainder? I think 2 can go. When 2 divide 12, you have 6. You still divide it again. What else can go to 6 without a remainder? What lowest number can go to 6 without a remainder? 2 can still go. You have 3. And then finally 3 will go. You have 1. So at the end of the day, you have discovered that we have broken 12 down all the way to 1. So what are the small numbers that created 12? And that are the two small numbers are 2 multiplied by 2 multiplied by what? 3. And that will give you what? 12. This is referred to as the lowest common multiples of that particular number. So I believe you can find the LCM of as many numbers as possible. So let's take another example. What is the LCM of 40? How do we find the LCM of 40? So to find the LCM of 40, you simply take the same approach. You write 40 and ask what smallest number can divide 40 without a remainder. I think 2 can go. And when 2 go into 40, you have 20. What also small number can go into 20? 2. 2 go into 20, you have 10. What small number can go into 10? 2. 2 go into 10, you have 5. What small number can go now? 5. And you have 1. So the LCM of 40 is what? 2 multiplied by 2 multiplied by 2 multiplied by what? 5. And that will give you what? 40. That is the LCM. Now in fractions, whenever you're dealing with the arithmetic operation of fractions, you need to understand how to find the LCM of numbers, because that will be a big plus whenever you're dealing with arithmetic operation of fractions. So let's say you are asked to find the LCM of two numbers, let's say 9 and 12. How do you take care of that? To find the LCM of two numbers, all that you're required to do is you can simply find the LCM of the numbers separately and then look out for the common factors that are found between the two numbers and collect them together. That is the LCM. Or you decide to go ahead and take the LCM of both of the numbers. So I think the best way is to take the LCM of the two numbers together. So let's quickly do that. So we have write 9 here, I write 12. So we ask ourselves, what lowest number can go into 9 or 12? The lowest number that can divide 9 or 12 is 2. Although 2 cannot divide 9, but 2 can take care of 12. And when since 2 cannot divide 9, you bring 9 down. But 2 can divide 12. When 2 go into 12, what do you have? You have 6. What number can still go? I think 2 can still go. When 2 go into 9, it cannot work. You bring down 9. 2 can go into 6. And when 2 go into 6, you have what? 3. What number can go now? 2 can no longer go because we have 3 here. So 3 can go. 3 is the lowest number that can go. And when 3 go into 9, you have 3. And when 3 go here, you have 1. What else can go? I think since this one is already 1, so remaining this guy, 3 can go. And when 3 go into this, you have 1. And this becomes 1. So at the end of the day, the LCM of 9 and 12 is 2 times 2 times 3 times 3. And what is it? 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is what? 36. And that is the LCM of 9 and what? 12. Now, the concept of LCM is very, very important when dealing with what? Fractions, because before you perform simple arithmetic operation with fractions, you must find the LCM of one or two numbers before you get started with the problem. So let's take one more examples on LCM. Now, let's say you're asked to find the LCM of four numbers. Let's say 6. Find the LCM of 6, 4, 12, and 3. What is the LCM of 6, 4, 12, and 3? The best way to work on that is to write down the number 6, 4, 12, 3. Then you ask yourself, you begin with the lowest number, 2. 2, can 2 divide any number here? Let's check. Can 2 divide 6? Yes. So it means that it's a goal. So we go ahead. 2 into 6, you have what? 3. Can 2 go into 4? Yes. When 2 go into 4, you have what? 2. Can 2 go into 12? Yes. When 2 go into 12, you have what? 6. Can 2 go into 3? No. You bring down what? 3. What's the next number? What small number else can still divide this answer that we got here? I think 2 can still do the job. When 2 go into 3, it cannot work. You write down 3. 2 can go into 2, you have 1. 2 can go into 6, you have what? 3. 2 cannot go into 3, you put down what? 3. I think we are done with 2. We move to the next number, which is 3. 3 go into 3, you have 1. 3 go into 1, you have 1. 3 go into 3, you have 1. 3 go into 3, you have 1. Now, understand this. Anytime you are dividing numbers, finding the LCM of numbers, and the last result you got is 1, 1, 1, you are done with the LCM. That marks the end of your division. So to evaluate the LCM now is going to be the LCM of these four numbers is equal to 2 multiplied by 2 multiplied by 3, which is what? 2 times 2 is what? 4. 4 times 3 is what? 12. And that is the LCM of 6, 4, 12, and what? 3. So that is the concept of LCM. Now let's get down with the arithmetic operation involved in fractions. The first arithmetic operation we are going to look into is addition. Addition operation. Now, how do we add fractions? To add fractions together, all that you are required to do is a few steps. So let's take an example to demonstrate how addition is carried out in fractions. So let's say we have 1 over 2 added to 2 over 3. How do we find the how do we add these two fractions? To add two fractions like this together, the first step is to do what? Find the LCM. Step 1 is find the LCM of the denominators. And then step 2 is use that LCM, use the LCM to simplify the problem, and you're good to go. Just 2 steps. Find the LCM of the denominators and then simplify the problem. So let's get started. So the first step is, let's take the denominators. Between 1 and 2, which is the denominator? 2. Write it down. Between 2 and 3, which is the denominator? 3. So we find the LCM. The LCM of 2 and 3 is simply 2 go here, you have 1. 2 cannot go into 3, bring it down. 3 go into this 1, 1. So the LCM is 2 times 3, which is what? 6. Now, I haven't gotten the LCM, which is what? The LCM is 6. So what we do next is to do what? We draw a line and put down that 6 here. Then we begin the simplification operation. Now, once you draw a line and put a 6, the next stage is to do what? Take each of the fractions and multiply them with what? The LCM that you got. So we take 1 over 2, we multiply by what? 6. We add it to 2 over 3, and then we multiply it by what? 6. Remember, since I'm dealing with fraction, this can be 6 over 1, 6 over 1. Notice that any number standing alone means that number over 1. So let's quickly simplify this further. So to simplify this is, I can see that 2 can cancel 6. And when 2 go in itself is 1. When 2 go into 6, you have what? 3. So what I have here is 1 multiplied by 3 added to what? What is going on here? 3 can take care of itself as 1. 3 go into 6, you have 2. So what I have here is 2 multiplied by what? 2. And everything is divided by what? 6. So the next stage is to do what? Simplify further. So to simplify, we say 1 times 3, you have what? 3. We add 2 times 2 is what? 4. Divided by what? 6. So the answer is 3 plus 4, which is what? 7 over what? 6. And that is the final answer. You can simplify this further into what? Into a mixed fraction if you so desire. So if we want to break it down into a mixed fraction, what do? We simply divide 7 by 6. Remember, when you share 7 stuff by 6 persons, they are going to first of all get 1, 1, and there will be a remainder of 1. So it's going to be one whole number, 1 over what? 6. So let's take another example on addition operation with fractions. So let's still on addition operation. So let's take example like this. Say 5 over 6 plus 3 over 4 plus 5 over 12 plus 2 over 3. Simplified. Now to tackle this problem, remember the first stage is a very simple stage. Take all the denominators and find their LCM. That's just it. So let's take the denominator. What's the denominator of 5 over 6? It is 6. What's the denominator of 3 over 4? It is 4. What's the denominator of 5 over 12? It is what? 12. The denominator here is what? 3. So let's find the LCM. The LCM will be, ask ourselves, the lowest number that can divide any of this number without a remainder. I think 2 can go. And when 2 divides 6, you have 3. 2 into 4, we have what? 2. 2 into 12. When 2 go into 12, 12 star, we have 6. 2 cannot go into 3, just bring it down. So what else can go? I think 2 can still divide because of 2 here. So when 2 go in, 2 cannot go into 3, so you bring it down. 2 go into 2, you have 1. 2 go into 6, you have what? 3. 2 go into 3, it cannot work, to bring it down. So what's the next stage? Since 2, we are done with it. I think 3 can go now. When 3 go into this, you have 1. 3 here, 1, 1, and 1. So the LCM of this whole denominator is 2 multiplied by 2 multiplied by 3. So what is it? We evaluate that 2 times 2 is 4. 4 times 3 is what? 12. And that is it. So having gotten the LCM as 12, the next stage is to do what? Draw a line and write the 12 at the bottom. So once we draw a division line and write the 12 at the bottom, what's the next stage? The next stage to do is to do what? Take each of the fractions, each of them, and multiply it by the what? By the denominator, by the LCM found. So let's take this fraction. 5 over 6. We multiply it by what? 12 over 1. We add it to the next fraction. 3 over 4. We multiply by what? 12 over 1. Added to the next fraction. 5 over 12. multiplied by 12 over 1 added to the next fraction 2 over 3 multiplied by 12 over 1. Feel free to pause the video and finish up the problem. So let's continue. So in this case, what's the next thing? We'll do what? We simplify. So to simplify this, we have, now something can divide. We know that 6 can go into 12. How many times? 2 times. Because 6 times 2 is 12. So this will give us 2 here. 4 can go into 12. How many times? 3 times. 12 can go into 12 just once. 3 can go into 12. How many times? 4 times. Now, having divided this, what do we have left? We have 5 multiplied by 2 here. Then we have 3 and 3, that is plus 3 multiplied by 3 added to, we have 5 multiplied by 1. It's 5 multiplied by 1 added to, we have 2 multiplied by what? 4. That is 2 multiplied by what? 4. Everything divided by what? 12. Now let's continue with this. So what's the next stage? The next stage is to do what? We simplify further. So to simplify this further, we are going to multiply out of the numbers. So here we have 5 times 2 is what? 10. Plus 3 times 3 is what? 9. Plus 5 times 1 is what? 5. Plus 2 times 4 is what? 8. Everything divided by what? 12. So the final answer to this problem is going to be, so let's add what we have at the top. 10 plus 9 is 19. 19 plus 5 is 24. 24 plus 8 is 32. So we have 32 divided by what? 12. So the next thing is to do what? So that is the final answer. We can simplify this 32 over 12 further by looking for a number that can break it down into a smaller term. Remember, we are dealing with simplification. So anything that will give you a smallest value that cannot be divided, that is the final answer. So what can divide 32 and 12? I think 2 can go. And when to divide 32, you have 16. When to go into 12, you have what? 6. Can anything still go? 2 can still go. And when to go into 16, you have what? 8. When to go into this, you have 3. The final answer becomes 8 over 3, which is an improper fraction. To be converted to a mixed fraction, you have 8 into 3. How many times will 3 go into 8? If you have 8 stuff and you want to share it among 3 persons, so these are the 3 guys, first guy, second, and the third guy, to be shared 8 things to. You have 1, 2, 3. It will go 3 times. How many is remaining? Just 1, 2, 3, 4, 5, 6, 7, 8. So it's going to go the how many? 2, 2. Remainder what? 2. So you write that 2 whole number 2 over 3. And that is the final answer. So that's all for addition operation with what? Fraction. Now let's take a look at addition of mixed fraction. What happens when you have a mixed fraction being added together? How do you take care of that problem? So if I have a mixed fraction added together, let's say I have 2 whole number 2 over 3 added to 1 whole number 1 over 2. How do I take care of the problem? The procedure is simple. So to add numbers involving mixed fractions, the best way to go about it is to add the whole numbers part and then you add the fraction part. Now understand this. A mixed fraction written as 2 whole number 2 over 3 simply means 2 added to 2 over 3. So if I have 3 plus 1 over 2, it is going to give me 3 whole number 1 over 2. If I have 4 plus 2 over 3, it means 4 whole number 2 over 3. You can tell me what will happen if I have 5 plus 3 over 10. It's going to be what? 5 whole number 3 over 10. Just like that. So if you have a whole number adding to a fraction, you just simply write the fraction by the side of the whole number, and then you now do what? Write down the fraction. That's it. So let's go back to the problem. So since we are trying to find out the addition of this mixed fraction to that mixed fraction, what we're going to do is to do what? We first of all add the 2 whole numbers together. So to add the two whole numbers is going to be 2 plus 1, and that is what? 3. Then we add it to the fractions. So let's deal with the fractions. So to add these two fractions together, we take them aside. We can take them aside and write it as 2 over 3 plus 1 over 2. So to take care of this, what's the LCM of 3 and 2? The LCM of 3 and 2 is simply 3 times 2. So 3 times 2, which is what? 6. You can verify that out. So this is 6. We draw a line and put 6. So we simply multiply each of the fractions by what? 6 over 1. Multiply 1 over 2 by what? 6 over 1. And when that happens, what do we have? We have that 3 here can cancel 6, you have 2. 2 here can cancel 6, you have what? 3. So what do we have? We have 2 multiplied by 2, and that is what? 4, plus 1 multiplied by 3, and that is what? 3. Everything divided by what? 6. So what do we do next? So we evaluate this. So we simply have that 3 is the whole number part added to 4 plus 3 is what? 7 over what? 6. So 3 plus 7 over 6 is simply 3 whole number, 7 over 6. And that is the answer. So that is how to add mixed fractions together. Simply add the whole numbers and then add the fractions. So let's take another example involving addition of mixed fractions. So let's say we have two whole number 3 over 4. So we have two whole number 3 over 4 added to 8 whole number 1 over 2 added to 1 whole number 1 over 4. How do you tackle this problem? The first stage is to do what? Is to simply add up the whole numbers. So to perform the arithmetic operation on the whole number, we simply say 2 plus 8, and that is 10. 10 plus 1 is what? 11. We write the whole numbers down. Then plus, let's deal with the fractions. What do we have as a fraction? The fraction is 3 over 4 plus 1 over 2 plus 1 over 4. So to tackle this, we do simply take the denominators and find their LCM. So the LCM of the denominators are going to be, we write it as 4, 2, 4. So let's go ahead. 2 here, 2, 1, 2. 2 here, 1, 1, 1. So the LCM is 2 times 2, which is what? 4. So what we're going to do now is simply draw a line, write 4. Use 4 to multiply each of the fractions. 3 over 4 times 4 over 1 plus 1 over 2 times 4 over 1 plus 1 over 4 times 4 over 1. So what do? We divide. 4 here, you have 1. 2 into 4, we have 2. 4 into 4, you have 1. So what we have left is, so what we have here is 3 times 1, which is 3, plus 1 times 2, which is what? 2, plus 1 times 1, which is what? 1, divided by what? 4. Remember that there is the whole number here, 11, added to this. So we simply evaluate this. So what do we have? 3 plus 2 plus 1. 3 plus 2 is what? 5. 5 plus 1 is 6. 6 over what? 4. So the final answer is simply going to be 11 whole number plus 6 over 4, and that is the same thing as 11 whole number 6 over 4. That is the final answer. So you feel free to try as many problems as possible regarding the addition operation of fractions. Now let's try out the same process is applied when dealing with subtraction operation with fraction. So let's say we have a problem 1 over 2 minus 1 over 3. How do you tackle that problem? Best way is to do find the LCM 2 and 3. The LCM of 2 and 3 is simply 2 here 1, 3. 3 here 1, 1. So 2 times 3 is what? 6. So you draw a line 6. Use 6 to multiply each of the fractions. 1 over 2 times 6 over 1 minus 1 over 3 times 6 over 1. So we go ahead and divide. 2 here, you have what? 3. 3 here, 6, 3 here, you have what? 2. So what we have here is 1 times 3, which is what? 3. Minus 1 times 2, which is what? 2. Divided by what? 6. So 3 minus 2 is equal to 1 divided by 6, and that is the answer. So that's how to tackle subtraction operation of what? Fractions. Now you see how helpful our knowledge of LCM is in dealing with the arithmetic operation with fractions. Okay, let's take a look at multiplication and division operation of fractions. Now before we move into this, I want you to understand something. Notice that what we are dealing with here is fraction. As a matter of fact, we are using a number, a given set of number, that we can call that number any number. It can be a 2 or a 3. And we are dividing, using that number to divide another number. Let's say we can call it 3, or we can call this one 5, or any number as the case may be. Remember, there is a division operation here. Now, anytime you are multiplying fractions, you can perform a cross division and that what fraction. Let's say we have this example now. You can decide to multiply the numerators together. Let's say 2 times 3 will give you what? 6. 3 times 5 is what? 15. And then you can simplify. Or you go ahead and simplify mere cross division. So I can use this 3 here to divide that 3 on the other side of the fraction. And when I do that, and I'm left with what? 3 here is 1, 3 here is 1. So what I have here, I can now simplify as 2 times 1, 2 divided by what? 5. And that is the answer. So multiplication allows us to cross divide numbers as the case may be. So we can decide to multiply the numbers out and then simplify, or we cross divide the numbers, that is, we simplify and then multiply. So whichever way that works best for you or you understand better, that is the way you implement. So let's take another example. Let's say we have 1 over 2 multiplied by 3 over 4. So to go ahead and deal with this guy is we ask ourselves, can this be simplified cross-divisionally? No way, we cannot simplify because 3 cannot, there's no number here that can be divided by 3. So we simply go ahead and multiply the numerators and the denominators. So the numerator, 1 times 3, we have what? 3. 2 times 4 is what? 8. And that is the answer. Now let's say we have a problem like this. 1 over 2 multiplied by 8 over 3 multiplied by 15 over 4. How do we tackle this problem? Now notice that you can simply multiply all the numerators and the denominators and then you simplify. But we can still simplify here and then multiply the numerator and the denominator so as to have our final answer. So how do we simplify here? Notice that notice that 2 can divide 8 here, and when 2 go into 8 you have 4. And notice that I can still use this 4 to divide this 4 that is here. And then what I have left is simply 1 and 1 here and 15. And also notice that 3 can go into 15, and when 3 divide 15 you have what? 5. So what do I have? I simply have 5 multiplied by 1 multiplied by 1 divided by 1 times 1 times 1, and that is what? 5 multiplied by 1 is 5. 5 times 1 is still 5. So we have 5 over 1, which is something as what? 5. And that is the answer. So multiplication allows us to cross divide. In multiplication, you can divide any number of your choice. Now let's take a look at some division operation with fractions. Let's say you have some fraction. Let's say one whole number, let's say 2 over 3 divided by, let's say, 9 over 4. How do you tackle this problem? Sorry, 4 over 9. How do you tackle this problem? You have one whole number, 2 over 3 divided by 4 over 9. How do you solve this? Now to tackle this problem, you simply need to do what? You need to convert the division sign to multiplication what? Sign. That's the best way to divide problems involving fractions. Anytime you have two fractions that are to be divided, you simply convert the division sign to multiplication sign. And when you do that, this side, when you change this division sign to multiplication sign, this side will change their positions. They will interchange their positions. And when that happens, you can now go ahead and apply the simple rule of multiplication and simplify your problem. So in this case, I'm going to have one whole number, 2 over 3, multiplied by, interchanging of position, you have 9 over 4. So once that happens, now, anytime you are multiplying or dividing numbers, and the number involves a mixed fraction and an improper fraction, or a mixed fraction and another kind of fraction, the best way to do is to do what? Make all the fractions to be of the same range, of the same type. So the best way to go about is to do what? Since this one is an improper fraction, but this is a mixed fraction, I will convert this mixed fraction to an improper fraction, and then I will go ahead with my multiplication. So let's convert this mixed fraction to an improper fraction. To do that, we simply say 3 times 1, and that is 3, plus 2, that is what? 5. So we have 5 over 3 multiplied by 9 over 4. So let's quickly simplify. We can simplify 3 here, 1. 3 into 9, you have 3. So the final answer can be 5 times 3, and that is what? 15, all over what? 4. And that is the final answer, which you can still take it back to an improper fraction, to a mixed fraction, by dividing 15 by 4. So when you share 15 among 4 persons, what will you have? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So they will receive 3, 3, remainder 3. So it's good. The answer is going to be 3 whole number, remainder 3 over 4. And that is the answer. So anytime division is involved, the best way to go about the problem is to introduce multiplication. And when you introduce multiplication, the number by the side will interchange their its position. Now let's look at problems that involves a mixture or combination of arithmetic operations. So let's say we have problems like this: 1 over 2 of 3 over 4 plus 5 over 15. How do you tackle this problem? Notice that there are two operations here. We have off and we have addition. So how do we tackle this problem? Now, to solve problems involving a mixture of arithmetic operations, what you are required to remember is the concept of BODMAS. BODMAS is an acronym for brackets of division, multiplication, addition, and subtraction. Now, anytime you are dealing with BODMAS, it allows you to know the particular problem to tackle first. Anytime you are faced with fractions or combination of fractions that has multiple arithmetic operation. So the best way to go about is to simply write down BODMAS and tackle the problem in accordance with the rule of BODMAS. So what does bracket? Bracket means look out for the problems that is in the bracket and deal with the problem in bracket first. And after which you move to the next stage, which is off. Look out for the problems involving off. Off simply means multiplication, although it's a special kind of multiplication, but just multiplication, that's what it means. Off means multiplications. After multiplication that involves off, you move toward division. After division, multiplication, the real multiplication, involving times, addition, and what? Subtraction. So another name for multiplication is off. So anytime you see off, know that it is another word for multiplication. So let's quickly solve this problem. Now, to tackle this problem, the question says 1 over 2 of 3 over 4 is added to 5 over 15. So to solve this problem, we simply write down our BODMAS and ask ourselves, is there any bracket in the question? No. Any off in the question? Yes. So we tackle the ones that involves the off. So this and this involves off. So we tackle it first. 1 over 2 multiplied by 3 over 4. So what do we have? We have 1 times 3, that is what? 3. 2 times 4, and that is what? 8. So we have tackled that problem. What we have here is 3 over what? 8. So we write it down as this is equal to 3 over 8 plus 5 over 15. So since there is only two operations here, so after dealing with of, you will now proceed to the addition. So let's add the number. So to add, we simply do what? Find the LCM of 8 and 15. So to find the LCM of 8 and 15, we go ahead. So what's the LCM? 2 here, you have 4. 2 cannot go into 15, you write it down. 2 here, you have what? 2. It cannot work. 2 here, you have 1. It cannot work. So you have what again here? 3 into 15, you have 1. 3 here, 5. And then 5, 1, 1. So what's the LCM? The LCM is 2 times 2 times 2 times 3 times 5. So 2 times 2 is what? 4. 4 times 2, 8. 8 times 3. 8 times 3 is 24. 24 times 5. And that is 120. So the LCM is 120. So we simply draw a line as usual, and then we draw a line and write 120. So we take each of the numbers and evaluate. So we take the fraction 3 over 8 multiplied by 120 over 1 added to 5 over 15 multiplied by 120 over 1. So we quickly evaluate and see what we have. So when we do that, we have that 3 over 8, 8 into 120 will give us what? 15. 15 into 120 will give us 8. So we simply solve and we have 3 times 15, and 3 multiplied by 15 is what? 45, added to 5 times 8, which is what? 40, divided by what? 120. And when this is added together, you have that this is what? 85 over 120, which you can simplify further. So let's go ahead and simplify that. We have 5 into 85 here, we have 17, and 5 into 120 here, we have 24, and that is the answer. Now, try this problem out yourself. How do we solve a problem like this? 2 whole number 1 over 6 plus 3 whole number 3 over 5 divided by 1 whole number 1 over 8. Feel free to pause the video and implement the strategy to solve this problem. Now, anytime you are faced with a problem like this, remember your BODMAS. BODMAS. So let's try out and see what we have here. Bracket, any bracket? Yes, there is a bracket. So let's deal with what is inside the bracket first. So to deal with what is inside the bracket, we have 3 whole number 3 over 5 divided by 1 whole number 1 over 8. Now, anytime you have a division or multiplication operation bounding two fractions, probably a mixed fraction, the best way to solve the problem is to convert that mixed fraction to an improper fraction. And once you do that, you can now go ahead and evaluate. So let's convert the mixed fraction to improper fraction. So to do that, we have 5 times 3 is what? 15. 15 plus 3 here is what? 18 all over what? 5. Now we put that divided by 8 times 1 is 8. 8 plus 1, 9 divided by what? 8. Good. Now we have converted this to an improper fraction. The next stage is to do what? Is to simplify. So let's divide this by this. Remember what I told you. To divide two fractions, you simply convert the division sign to multiplication sign. And when you do that, this number here will interchange their position. So when you change this to multiplication sign, that interchanges its position. So let's do that. So when we have that this is 18 over 5 multiplied by 8 over 9. So when that happens, we can simplify if we so desire. So let's simplify. 9 into 18 is what? 2 times. So let's simply solve that problem. So simplifying it, we have 2 multiplied by 8. 2 times 8 is what? 16 divided by 5. This is 1. 5 times 1, which is what? 5. So this whole problem, we are through with this, guys. So this is this plus, so what we have here in the bracket is 16 over what? 5. It is important to keep track of what you are doing so that you don't think that this is the final answer, but this is not the final answer. This is just the one in the bracket. So we are through with that. So we move on to the next stage, which is what? Addition. So let's add this to this. So to add this to this, we simply do what? Convert this guy back to his mixed fraction. Since this one is a mixed fraction, we can still convert this to mixed fraction. So when we convert 16 over 5 to mixed fraction, we have that this is 2 over 1 over 2 whole number 1 over 6 plus 5 will go how many times to form this a mixed fraction? 5 times 3 is 15, so it will go 3 times, remainder 1 over 5. So we have converted this to a mixed fraction. What do? We add. So to add mixed fractions, we simply add a whole number part. 2 plus 3 is what? 5. So we simply find the LCM of 6 and 5. The LCM of 6 and 5 is simply 6 times 5, which is what? Which is 30. So when we do that, we simply take the fractions and multiply it by the LCM. So we take the fraction multiply, so we take 1 over 6, multiply it by what? 30 over 1. We add it to 1 over 5 multiplied by 30 over 1. So that will give us 5 whole number. What? So 6 go into 30, it will go there 5 times. 5 go into 30, will go there 6 times. So I have 1 times 5, which is what? 5, plus 6 times 1, which is what? 6, divided by what? 30. So what we have here is 5 whole number. 5 plus 6 is what? 11, all over what? 30. And that is the final answer. So pretty cool, right? Now, one thing is certain here. You can feel free to pause the video and try as many problems out yourself. So let's take a look at this final example. Let's say we have 1 over 2 into 2 whole number 1 over 4 plus 5 whole number 1 over 4 divided by 1 whole number 7 over 8. Feel free to pause the video and simplify this problem. Remember the rule of BODMAS. Make sure you tackle what is in the bracket first, and then use this rule and you will not mix out anything. So how do we tackle this problem? So to solve this problem, the first stage is to what? Look into our BODMAS and carry out the operation. So what we have here is bracket. So let's deal with the one in the bracket. So to deal with what we have here in the bracket is 2 whole number 1 over 4 added to 5 whole number 1 over 4. So how do we take care of that? So the first stage is to do what? To add these numbers up. So if I add this one, I can take them out and deal with them. So if I take them out, I have 2 whole number 1 over 4 added to 5 whole number 1 over 4. So what do? I add the whole numbers together. So if I add 2 and 5 together, I have what? 7 whole number. Then the fractions, the LCM of 4 and 4 is still 4. So we just draw a line and put 4 there. 4, we now use this fraction to multiply by 4. 1 over 4 times 4 over 1 plus 1 over 4 times 4 over 1. So what do we have? 4 can cancel 4, you have 1. 4 can cancel 4, you have 1. So what we have here is 1 times 1, which is what? 1. Which is 1 plus 1 times 1, which is 1, again, divided by what? 4. So 1 plus 1 is what? 2 over 4. And 2 over 4 is something as 1 over 2. So that is what we have here. So we have here in completion as what? The fraction is 1 over 2. So the whole number is 7. So we have 7 whole number 1 over 2. And that is what is at the top here. So we simply go ahead and put it in there. And put it here. So everything here is what? 7 whole number 1 over 2. So what's the next stage? The next stage is to do what? Divide these two numbers. So to divide this and this, what do? We change them to what? To improper fractions. So to change this to improper fraction, we have 2 times 7 is what? 14. 14 plus 1 is what? 15 all over what? 2. So I have 1 over 2 here, a bracket, 15 all over 2, divided by what? Change this to improper fraction, you have 8 times 1, which is 8. 8 plus 7, and that is what? 15 all over what? 8. So let's go ahead and simplify. Now, this is what we have now. Remember, change this to multiplication sign. What happened? So we change the division sign. This is division. So simplify, we have 1 over 2 into 15 over 2 multiplied by this will exchange their position. You have 8 over 15. So what happens? Something can divide. 15 can divide 15. You have 1, 1. 2, 1 here. 2 can divide 8 and you have what? 4. So what I have here, everything here is 4. So what I have here is 1 over 2 multiplied by what? 4. Because 4 is over 1 and anything over 1 is that same number. So what happened? This is 4 over 1. Remember that 2 can still divide this 4 and you have what? 2. So the whole fraction that we have before is simply 2. So it simply this implies that fraction, this problem, whereby we have 1 over 2 into 2 whole number 1 over 4 plus 5 whole number 1 over 4 divided by 1 whole number 7 over 8 is simply equal to what? 2. And that is the final answer. Notice how we broke this down. The most important thing to learn is the steps involved, not the solution. If you can, problems in mathematics are very unique. It is important to understand the steps that are involved. Stick to your BODMAS and you will not have a problem with arithmetic operation involving what? Fractions. Now let's take a look at another subtopic, order of magnitude. In this concept, we are going to understand how fractions can be arranged in ascending and descending order. How can you arrange fraction in ascending and descending order? Now, what is ascending order? Ascending, as the name implies, means increasing. If I want to arrange numbers in ascending order will start from the lowest number to the highest number. Example is, if I have numbers like 2, 3, 1, 2, 5, 8, and I'm asked to arrange this number in ascending order, what will come first? 1, followed by who? 2, followed by the next 2, followed by 3, followed by what? 5, and then end with what? 8. This is called arrangement in ascending order, from the lowest number to the highest number. Now, what about descending order? The opposite is called descending order, whereby numbers are arranged from highest number to the lowest number. Example, from this same arrangement, we can start with what? 8, followed by what? 5, followed by what? 3, followed by 2, followed by 2, and what? 1. This is called arrangement in descending order. That is from the highest number to the lowest number. Ascending order is from lowest number to highest number. Descending order is from highest number to lowest number. So use this to remember that this is ascending. It is increasing from lowest to highest. This is descending. It is coming down from highest to lowest. And that is how to tackle problem. Now, what if the problem involves fractions? How do you know that a fraction how can you arrange fractions in ascending or descending order? Now, to arrange a fraction in ascending or descending order, there are some few steps to carry out. So let's take an example. Let's say we have 5 over 6, 3 over 4, 5 over 12, 2 over 3. Question says, arrange these fractions in ascending order. How do you do that? Now, to arrange a given fraction in ascending order, you simply need to do what? Find their LCM. Find the LCM of the denominators. So you need to test it in terms of LCM. So this fraction, I don't know which one is the greater fraction. I don't know which one is the smallest fraction. So to find out the one that will come first and the one that will come last, what I will do is to do what? I will find the LCM of the denominators. So the LCM of 6, 4, 12, and 3 is what? 6, 4, 12, and 3. So let's find the LCM. 2 can go here, you have 3. 2 go into 4, you have 2. 2 go into 12, you have what? 6. 2 go into this, you have 3. 2 can still go. 2 go into 3, you have 3. 2 go into 2, you have 1. 2 go into 6, you have 3. 2 cannot go into 3, you bring it down. So 3 can go 1, 1, 1, 1. So the LCM of 6, 4, 12, and 3 is what? 2 times 2 times 3, and that is what? 12. 2 times 2 is 4. 4 times 3 is what? 12. Now, having gotten the LCM, the next stage is to do what? The LCM, to multiply each of the fractions one by one. So we take the fraction. The first fraction is 5 over 6. We multiply it by the LCM, 12. Then we take the second fraction, 3 over 4, multiplied by the LCM, 12. We take the third fraction, 5 over 12, multiplied by the LCM, 12. We take the last fraction, 2 over 3, multiplied by the LCM, 12. And after which we evaluate. 6 can go into 12, and you have what? 2. So you have 5 times 2, and that is 10. 4 can go into 12, and you have what? 3. 3 times 3, and that is 9. 12 can go into 12, you have 1. 1 times 5 is what? 5. 3 can go into 12, and you have what? And you have 4. 4 times 2 is what? 8. Now from this, you can see that the numbers are very clear. Now what does that tell you? It tells you that the highest fraction here is the one that produced 10. The lowest fraction is the one that produced 5. So let's arrange it now in ascending what? Order. So to arrange the fractions in ascending order, which one will be the lowest fraction? The lowest fraction is the one that has 5, and that is 5 over 12. So 5 over 12 comes here. Followed by who? Followed by the one that gave 8, and that is 2 over 3. So 2 over 3 follows up. Then the next one is the one that gave 9, that is 3 over 4. 3 over 4 follows it. And then the last one, the one that gave 10, that is 5 over 6. 5 over 6. So this arrangement is in ascending order. So that is how to take care of that problem. So you see that the trick here is for you to take the denominators and find their LCM. And once you find the LCM, use the LCM to multiply out the fractions. And then you get a reasonable number that you are going to use as a benchmark for judging the fractions in terms of the lowest fraction and the highest fraction. So let's take another example to solidify our understanding on ascending and descending order of fractions. So let's say we have these fractions. We have 5 over 7, comma, 3 over 4, comma, 1 over 2, and 9 over 14. The question says, arrange this fraction in ascending order and in descending order. How do you solve that problem? To arrange this fraction in ascending order and descending order, we need to know which of this fraction is the highest fraction and the one that is the lowest fraction. To solve this, we simply find the LCM of the denominators. So let's take all the denominators and find their LCM. 7, 4, 2, 14. Let's find the LCM. What can divide without the remainder? Lowest number, 2. 2 cannot divide 7. You write down 7. 2 can divide 4, you have 2. 2 into 2, you have 1. 2 into 14, 2 can go into 14 to have 7. So what else can go? 2 can still go. 2 cannot go into 7, you have 7. 2 can go into 2, you have 1. 2 here, 1. 2 here. What else can go? Obviously, it is 7. 7 here, 1, 1, 1. So the LCM is 2 times 2 times 7, and that is 2 times 2 is 4. 4 times 7 is 28. And that's it. So having gotten the LCM, we now start our test process. So let's test the numbers, each of them. We have gotten the LCM. The LCM is 28. So let's use that and test the numbers to know the one that is the highest number and the one that is the lowest number. So we pick the fraction one after the other. We pick the first fraction, 5 over 7, multiply it by the LCM. So we test that over 1. So we test the second fraction, 3 over 4, multiplied by the LCM. Take the third fraction, 1 over 2, we multiply by the LCM. Take the last fraction, 9 over 14, we multiply it by the LCM. So after which we evaluate. 7 can go into 28. How many times? 4 times. And when that happens, you have that 4 multiplied by 5 is what? 20. So 4 can go into 28. How many times? 7 times. When that happens, 7 times 3 will give you what? 21. 2 can go into 28. How many times? 14 times. 14 times 1 is what? 14. And then 14 can go into 28 how many times? 2 times. 2 times 9 is what? 18. Now that we've seen the real picture of how these fractions are, we can now arrange them in ascending and in descending order. So let's arrange them in ascending order first. So notice that 5 over 7 gave 20, 3 over 4 gave 21, 1 over 2 gave 14, and 9 over 14 gave what? Gave 18. So which of them is the lowest number? So to arrange this number in ascending order, we'll have that which one comes first? The lowest number here is 14 and 1 over 2 gave it. So we have 1 over 2 coming first, followed by which number? The lowest number, which number is following it up? After 14 comes 18, so 9 over 14 follows up, followed by which number? 5 over 7, and then the last number, which is the highest number, which is 3 over 4. So this is arranged in ascending order. Now, in descending order will just be the opposite of the arrangement. So in the opposite direction, since this is an ascending order, so in descending order, we'll have 3 over 4 here, followed by 5 over 7, followed by 9 over 14, followed by 1 over 12. And that is the answer. So that's gonna do for this video on fractions. I believe you were able to grasp something on the concept of fraction. So see you guys in the next video.